The concept of Starlink originated in 2015 when SpaceX, a company founded by Elon Musk, announced plans to build a satellite constellation to provide global broadband internet coverage. The primary goal was to bridge the digital divide by bringing reliable internet access to underserved and remote areas around the world. In February 2018, SpaceX launched its first two prototype satellites, called Microsat 2A and 2B, to test the technology and feasibility of the concept. These satellites were successfully deployed into orbit, marking the initial step in the development of the Starlink system. Over the next couple of years, SpaceX obtained regulatory approvals from various national and international authorities to deploy and operate a large-scale satellite constellation. They received approval from the U.S. Federal Communications Commission, FCC, to deploy nearly 12,000 satellites in multiple orbital shells. In May 2019, SpaceX launched the first batch of operational Starlink satellites, consisting of 60 satellites, aboard a Falcon 9 rocket. This launch marked the beginning of the deployment phase for the Starlink constellation. Since then, SpaceX has been conducting regular Falcon 9 launches to deploy additional Starlink satellites. As of my last knowledge update in September 2021, SpaceX had launched hundreds of Starlink satellites, significantly expanding the constellation. The company began a public beta testing phase in select areas, allowing users to experience the internet service and provide feedback. It's important to note that the Starlink project is an ongoing endeavor, and SpaceX plans to continue launching satellites to expand coverage and improve the performance of the network. They aim to provide global coverage and eventually have tens of thousands of satellites in orbit. Starlink has already been launched and is currently operational. SpaceX has been conducting regular launches of Starlink satellites since 2019 to build out its satellite constellation. As of my last knowledge update in September 2021, hundreds of Starlink satellites have been launched, and the service was in the public beta testing phase in select areas. The exact timeline for the full deployment of the Starlink network and its availability in specific regions may vary. SpaceX has been actively launching satellites and expanding coverage, aiming to provide global broadband internet access. However, the pace of deployment depends on a variety of factors, including regulatory approvals, technical challenges, and the need to ensure the reliability and performance of the network. Here's a brief overview of how the Starlink system works. 1. Satellite constellation. Starlink plans to deploy thousands of small satellites into LEO, forming a constellation. 1. These satellites operate at an altitude of around 550 kilometers, 340 miles, much closer to Earth than traditional communication satellites. 2. Internet connectivity. Each Starlink satellite is equipped with communication equipment, including antennas and transceivers. 2. These satellites communicate with ground stations on Earth and with other satellites in the constellation to create a network of internet connectivity. 3. User terminals. To access the Starlink internet service, users need to install a small satellite dish terminal, called a user terminal, or dishy McFlatface, at their location. 3. The user terminal communicates with the Starlink satellites overhead, establishing an internet connection. 4. Satellite routing and handoff. As the user terminal communicates with the satellites, the data travels from the terminal to the nearest satellite in view. 4. The satellites then route the data through the constellation, relaying it from one satellite to another until it reaches a satellite above a ground station. 4. From there, the data is routed to the internet backbone, allowing users to access the internet. 5. Ground stations. Starlink also operates ground stations around the world to establish communication links with satellites. 5. These ground stations serve as gateways between the satellite network and the traditional internet infrastructure. 6. Global coverage. The large number of satellites in the Starlink constellation and their close proximity to Earth allows for near global coverage. 6. This is particularly beneficial for areas that lack reliable internet access due to geographical constraints or limited infrastructure. 7. Continuous improvement. Starlink is continually working to improve its satellite technology, including reducing the size and weight of the satellites, optimizing communication protocols, and enhancing network efficiency. 7. These advancements aim to increase the speed, reliability, and coverage of the Starlink internet service.